Alright, एक और क्वेश्चन करते हैं from past papers of refraction of light. So first part is state the speed of light in air. Now remember, speed of light in air and speed of light in vacuum is same. I don't know why this is a bit tera. Let me sort that out first because that will keep me disturbing. Alright, so here we go. Yes, so speed of light in air is remember you have to write units as well. So 3 into 10 to the power 8 meters per second. Right? Simple as that. Next question is part B. Figure 3.1, which is not to the scale, shows a ray of blue light, which is N, passing from air into glass block and refracting at the surface. So it's bending at the surface here. Something is happening. This is a glass block. This is coming from the air. Now the question is, as the light enters the glass, okay, you can't see that, so I'm going to push it a little bit ahead. And here you go. Yeah. So as light enters the glass, state what happens to the speed of light. This is what we learned in journal wave properties. So speed of light, when it enters from lighter to denser medium, it slows down. So it will decrease. So speed of light decreases. What happens to frequency? We know that frequency in waves remains same or it's unchanged, right? Nothing happened to it. What about wavelength? Wavelength also decreases. So there you go, that part is done, simple. But now let's go to the technical part, and that is the next one here, which says on figure 3.1, mark and label the angle of incidence I and of refraction R. तो सबसे पहले हमें वापस जाना है और हमें उस फिगर पे angle of incidence or angle of refraction को mention करना है. So let's do that. So in this, remember it's always between the normal. So here you go. This angle here is angle of incidence and this angle here is angle of refraction, right? With angle R. Now, the next part is the refractive index of glass for blue light is 1.5. The refractive index उन्होंने दे दिया is 1.5, right? A ray of blue light strikes the surface of a glass block at angle of incidence 89 degree. So angle of incidence is 89 degree here. Calculate the angle of refraction of light in the block. In this condition, what would be angle of refraction? Now remember, since in this case we can clearly see the light is coming from a lighter to denser medium, so for that we will use our formula, which is, just gonna sort it out a little bit. Yeah, there you go. So yes, so in that case the formula we're gonna use will be N is equals to sine I upon sine R. Now here if we apply the formula, so we have the values. So 1.5 is the refractive index, is equals to sine I, which is 89, and we need to find out angle R, right? Now if we swap this, so this becomes sine, yeah, so 89 upon 1.5 is equals to sine R. Now all we need to do is we can figure out this first, or simply we can say that from this we can go further ahead. I'm doing all these steps to tell you, otherwise you don't have to do anything after this. You can simply put in calculator and give me the answer of this, which you need to find out. But this is the mathematical steps I'm doing to let you know what is happening in terms of mathematics. So R is equals to sine inverse, and you go sine 89 upon 1.5. Now if I put these values in the calculator, so let me do that. So if I say that, okay, so we got shift sine inverse, it's sine 89, right, bracket close, divided by 1.5, bracket close. So that should give us answer is 41.8. So the angle of refraction we're gonna get is 41.8 degrees, and here we can write 41.8 degrees. That's the result. I hope that was clear. Is that question finished though? No, I don't think so, because it has a second part to it as well. Yeah, let me have a look. Yeah, sorry, my bad. This has a second part to it as well, and let's see that second part. Alright, so here we go, the second part of the question, and it says, explain why the angle of refraction of blue light in glass is always less than 45. Now, the idea is the maximum possible angle of incidence what we can get is 89.9, because at 90 degree it won't refract. So what does 90 degree angle of incidence means? So that means if we have an object like this, I hope that's visible. So if we have object like this, so some rays coming from here. Now in that case, if I draw normal here, so that is 90 degree of angle of incidence, in which case refraction won't occur. So the minimum angle it needs is 89.9. Now we have just figured out earlier that if we have the angle of incidence of 89, the angle we will achieve is 41.8. So we can do the same thing actually with 89.9. So if I put the formula here, R is equals to sine inverse, and the formula was sine 89.9 divided by 1.5 for the same material. So let's see, let's put these values in the calculator and let's see what comes as an answer. So we go sine inverse, so we put in values sine 89.9 bracket close divided by 1.5 bracket close and 41.81. So the maximum angle of refraction is getting is 41.81, and that is less than 45 clearly. So this proves, we have to show this working, and we have to say that, I'm going to write that actually as an answer, since angle of incidence cannot exceed than 89.9 degrees, and for that the angle of refraction is 41.81, which is less than 45 degrees, so that will always be the case. So there you go.